Okay, so we're going to talk about matrix inverses. And for our intents and purposes, the word inverse essentially means reciprocal. So the way that an inverse is denoted is there's a negative 1 power. Like, for example, if I were to do 2 and raise it to the negative 1 power, that would be the same thing as the reciprocal of 2. And the reciprocal of 2 is just flopping it, so you've got 1 over 2, right? Does everybody remember that that negative 1 power does that?
Yeah.
From way back when? So with a matrix, you can do an inverse, but you can't quite do a reciprocal. So there's a way that you can compute the inverse of a matrix so long as it's square. And that's something you need to know, is that only square matrices, meaning if the number of rows is equal to the number of columns, have inverses. And finding an inverse is actually pretty easy. So if we start out with some matrix A here, and I want to find out what matrix A inverse is, the process isn't too bad. So we're going to start with matrix A, and I'm going to use a 2 by 2. And all of the ones that you have to find inverses for on your homework today are 2 by 2. If it's a 3 by 3, you can just use your calculator. It'll be faster. So let's make this, let's say, 2, 4, negative 1, 3. So if we want to try and find A inverse, the first thing you have to find is the determinant of matrix A. And so the determinant of matrix A is 2 times 3 minus negative 1 times 4. So the determinant of A, I'm writing it det A, is equal to 2 times 3 minus negative 1 times 4. So this is 6 minus negative 4, which is 10. Now to find the inverse, I'm going to do 1 over whatever the determinant of A was, and that's the 10 plus u. And I'm going to multiply that not by A, but by a transformed matrix of A, a transformed version. And the transformed version is really not that hard. Like, what we're going to do for the inverse is flip A and D. So these two, the 2 and 3, they switch places. So it's going to become 3 and 2. And then opposite signs for the negative 1 and the 4. Positive 1, negative 4. I like to show you with numbers first. Like, in general, I'll show you with letters here. If you have a matrix that's A, B, C, D, then the inverse of that matrix is 1 over AD minus CB. This is the determinant, which is what we found up here, times, like this is the, in letters, this is the algebraic version of what I just did. Does that make sense? Like, I just like showing the numbers first, because I think, like, I'm going way too fast.
Why do you switch signs?
I know, for the most part, for right now, just because I told you so. I'll explain more when we talk about using the inverse matrix, about where they come from. But for right now,
You don't switch them around.
no, you just switch their signs. A and D, you switch them around. C and B, you don't switch them around, but you switch their signs.
Well, it's negative, so you just change it.
Right, so like here,
So if they were both positive, would they both turn into negative?
Mhm.
Okay.
yeah, so I did negative, negative 1, which is positive 1, and then I did negative 4, which is negative 4. So D and A switch places, and C and B just become negative, but they stay where they are. Yeah?
What does the little determinant inverse thing have to do with flipping the rows? Because you didn't use the 1/10 to flip the two numbers.
No, so you want to think of it like it's the matrix version of doing the reciprocal. So like when we had 2 and you're taking it to the negative 1 power, you do 1/2.
Yeah.
The version of doing that for matrices is multiplying the determinant by this transformed version of it. I don't have a great answer for that right now because I want to show you guys how it's used first, and then I can explain it better. Is that what you're asking, or?
Yeah, I've done this. I just don't remember how I did it.
Okay.
But it's kind of making sense.
Okay.
It's
All right. So now the one step I can take further up here on this one is I can multiply 1/10. It's just a scalar. I can multiply it through to everything inside. So A inverse would end up being 0.3. 1/10 times 3 is 0.3. Negative 0.4. 0.1. And 0.2. If you were to enter this in your calculator, that's the version that you would get back out from your calculator for doing the inverse. And you can do the inverse on your calculator the same way that we were doing everything else. You just need to know where the inverse button is.
You still have to, after you multiply it by the 1/10, do you still have to solve it like normal?
No, for this, like this is all I'll be asking on most of today's stuff.
Okay.
Is just to take this matrix and then find its inverse, which would be
Not taking any further.
no.
Okay.
Tomorrow, when we start talking about decoding, we're going to apply the inverse to like breaking codes and stuff, which is how it's a part of how it's used in real life. So today we're just learning about the inverse itself. Not too bad. Should be super easy. Okay. So, time for today. Or I guess today is Tuesday, so unless you were gone last week, today I need the matrices, matrix multiplication, and determinants. So there's 3 things that are due today.
We need to slow down. We're being too proactive.
Hmm? I know. So much work. Jeez. And we're almost done with school too, and it's still leaving work. Sorry? Oh, yeah, yeah. Oh, jeez. Sure, that's fine. And then I showed everybody how to do it on a calculator too, so you might want to check.